into Galaxy window or something, and please find the camera of the hosting account, which is under the Samsung SA account, and you should be able to find that on what I'm showing to you guys right now, which is the board just toggling and on port B.
Is that the one where Wagdy was talking about 55H and AAH?
Exactly. Yeah.
It is?
We're gonna take a look. We're gonna take a look exactly how is that transfer in terms of coding in simulator a little bit later. Okay. So, but this is the physical.
All right.
This is how it performed on the board.
Yeah.
And you can see these LEDs. These LED, if you take a look on the side, it's gonna say over here. So it's gonna be PB7 all the way to PB0. So all the pins in the port B are connected to these LEDs.
Yeah.
So it means that when we controlling the bit that is sent to the port B, we connect it, it's gonna be on or off. So we know that in the future, I mean not in the future, like a little bit later, when we are taking a look at the code, we want to focus on port B because that's the bit that is controlling those LED. Okay. So now enough of the board result. Let's just step back to the simulator and also give me a second, see if I can switch back to, wait. How could I switch back to the screen share? What?
You're sharing.
So are you guys still able to see my screen share right now?
Yeah.
It's not even showing. Okay. All right, cool. Okay, I got it. Okay, cool. So yeah, so now stepping back to the simulator. Okay. So it still have the code on it. It's just I haven't executed. So right now, I want you to do one thing. So you want to click on this display updates as an option. So this allow you to see the live update when you are not stepping through. For example, if you want to just go to the end of the program, instead of only showing you the end result, it also show you how the result is changing when you executing through all of your instruction line. So you want to have this option enabled.
Like when you press go?
Okay. No, I haven't pressed anything. It's still on 2005.
Right.
You just want to hit that display update first.
Okay.
Okay. And then secondly, as I just mentioned a few seconds ago, we want to kind of like focus on what is the memory that is controlling the port B. Like basically, yeah, what is the memory? What are the location are the bit that is stored to control port B? And if you take a look in this code over here, let's just find what can give us a hint to find the address, all right? So here, if you take a look at this part, isn't this look familiar to you?
Yeah,
this is exactly the piece of code Wegdi showed you guys, Professor Wegdi showed you guys in the lecture. You store 55 into port B, and after the delay, so this is just jump to the subroutine. What a subroutine do is just it create a delay and then jump back to the main program. So you have that time gap between loading 55 into the port B and loading AA into the port B. So basically, if you only see it as see it in the ASMID window over here, it's hard to tell that what is the address of port B because it doesn't say over here. Just using that label to represent it. But the good thing is that since we also loaded in our simulator, when you hit to that line, it will show something like this. Instead of showing the label, it will show the exact address of what that label is representing, right? So once we get that important information, which is where the address of this port B, we can tweak the memory display section into that address. So we can take a look what are the live update for all the memory bits that's stored into those port B pin.
There is one. There is another stack operand before that, right? For example, after the stack on DDRJ and the stack on PTJ. How do we differentiate which stack is which?
So these two part, I believe it's just, this is probably more like Okay, so let me take a look a little bit further just to make sure. DDRB. Okay, so let's just say please also ask this to Professor Wegdi, because apparently he know the architecture of this board a little bit better than me. But from my experience, the way other processors work is that you're not only having one register for each of the port. For example, let's just focus on port B right now. You see there's DDRB and port B, two different labels, right?
Yes.
So usually when you are configuring a port, you have many options you need to get it done. You need to configure it either into input or output. You need to send a data bit. If it's input, you need to set it as input data bit. If it is output, you need to have a register plate to read the output. Sometimes you also need to have a register to configure the output circuitry. In my previous experience, you can maybe configure an output circuitry to be push-pull or be open drain. So you see, for a single port B, there are many registers to do separate settings on the port. Specifically, the DDRB are going to be the register that is like, the memory data in charge of setting this port into output or input. On the other hand, this port B label is representing, or say controlling, the data you want to send to this port. If this port is the output port, this is going to be the output data, where the output data of this port is storing. If this is C as the input port, this is where the input data of the port is storing. So these are many registers, each in charge of different configuration, or say each part like a separate part of the functionality of a specific port. Okay, so I hope that answer you a little bit clearer. And the way to tell them, like which is function as which, is that when you see the comment over here, you can see that this is the part where the program designer toggle all the LED. So this is where they make that final data, say output, or they send the data into that port to make those LED turn on or turn off. So you can even tell from here, it loads some data into the register A, and then directly store that data into this label port B to make your LED light on or off. So this definitely is going to be the label we care to figure out where's the output value of those port B are stored. Okay?
Right.
So with that in your mind, let's just step in from the simulator all the way to this line over here. And let's just to find out what is the address of the port B. Okay? So so right now we are at 2005 STA05, which is this line over here. So when you step, there's another LDA line. So there's gonna be extra 4 line over here to do loading and storing. And then we'll jump to the first line over here, LDAA 55 by next click. Okay, so focus on the next line over here. All right, so I'm gonna step in right now. Okay, see? So right now we are jumping to the first line, LDAA 55, right? So when we hit next, this line over here, STAA 01, is representing this line over here. So we can tell that this 01 is going to be the address of this port B. You know, this is probably a very brute force way to find it. You can definitely find, you know, what's the address of the port. You know, if you look back to the, you know, your textbook, take a look at the memory mapping for the whole processor. But given that we have these 2 software in our hand right now, I think this is a good way to find out the address of the port, given by the live feedbacks of the simulator. Okay, now we know 01 is going to be a the address of port B. So why not let's just set this into 01. Okay, so right now you can see it's right now showing all the value the data from memory address 0000 all the way to 0030. Okay, and we want to focus on this 01. Okay, and as you can imagine, when you executing the code in your board, it kind of created a infinite loop in this portion, because the way it like I believe Professor Wegde also mentioned it as well. This BRA basically means that you're branching to a label without any condition. Okay, we have, like, I think Professor also introduced what is BCC, BNE in the class. That two branching are conditional branching. It only branch to that label if certain condition is meeting. But BRA is a branching instruction without any condition. So it's always kind of branch back to back when you're executing the program. So it kind of created an infinite loop. So that's the reason why the LED is always kind of toggle without a N.
Right.
Okay. So if that similar effects carry through this simulation panel we have, we should see that when we hit this go button over here, not only all the register will change rapidly because of all the loading and storing, also the memory byte that is connecting, or say that is controlling the output port of port B, is going to switch from 55 to AA with a certain frequency, right? And that should matching the frequency of your toggling on your board if the executing frequency on the simulator and the board is in sync, which sometimes probably gonna cause some delay, but you can expect that it's gonna perform something similar. And right now, since we already find out where is the port B, which is exactly this thing over here, with the let me see if I can highlight it. Okay, I'm not able to highlight it, but this bit over here. So right now, I already have display update enabled. So if I hit go, which means to execute the whole program, it will jump into that infinite loop for me on the simulator side. And we should expect that these bytes are going to be changed from 55 to AA, toggle from 55 to AA with a certain frequency, right? So let's just do it. Okay. So before I hit go, any question or anything that is not clear, you want me to explain again?
Samson,